Hello everyone, we are Team Macalester and this is our final video report on the 2021 to 2022 GLEAM Lunar Robotics Challenge. Here's our whole team and our advisors. We didn't have a specific division of tasks, so every one of us has worked on multiple aspects in this project. We were not able to finish the system and deliver the exploration in time. However, we will be talking about the progress that we have made so far in this video report, and also the challenges that we faced and problems that we solved. So to start with, Paige will introduce you to our network system.
Hello, my name is Paige. I'm a junior at Macalester and a physics and economics major. I'm going to be talking a bit about our network, our XP network that we used on this project. Here you see a rough sketch of our network. Data would be collected from the sensors on our GLEAM unit, which is our main rover, and transmitted via XP to the central unit. Another XP module then carries the data back to Earth. We had quite a few challenges setting up the network. As a team, we had no experience with Arduino and very limited programming knowledge overall. We struggled with adapting programs for different boards, such as the Arduino versus TNC boards, and figuring out how to use the principles of the tutorials provided to apply to our system. I was also unable to make use of the XP library, which, for reasons unsolved, downloading it forced me to completely restart my IDE, completely uninstall everything, because it would corrupt everything and not allow me to use any libraries. We eventually decided to write our own code for the XPs and found it easiest to use two separate networks that we wired together on the central unit, one for transmitting the data from the rover to the central unit and the other to go from the central unit to Earth. We accomplished this after a lot of help from our advisor, Dave, through simple serial and software serial ports on our microcontrollers. We were able to send characters from the rover back to Earth, and our next step would be organizing the data from our sensors to send in a parsable package. For our sensors, using a mix of downloaded and self-written code, we were able to collect data and display it on the computer serial monitor. The next step here is to package it so that it can be cleanly sent and read through our XP network.
Okay, so now I will talk about our camera system. To briefly introduce myself first, I'm Chloe. I major in physics and math in Macalester. I worked mainly on the camera system, as well as partly on the network with Paige and partly on the 3D design. So this is our camera system. It's we have a Raspberry Pi 0W, a servo hat for the Raspberry Pi, which allows us to control the servo motors for the Pentel system. And then it's also used to control our flashlight. And here is our Raspberry Pi no IR photo camera. So we will connect the Raspberry Pi with our computer wirelessly through hotspot, which is basically through Wi-Fi. And then we will be able to enter an interface on the computer to control the camera, the Pentel system, and the flashlight. And we will also be able to stream video on that computer. So some basic, this is actually a very basic setup for a camera system, but we spent a lot of time trying to set it up and trying to make this work because of mainly two challenges. The first is that the camera that we have currently is actually the third camera that we have bought for this project, because for the first two cameras, we didn't realize that they actually did not work with the Raspberry Pi 0W that we have until very late. So we kept trying to install the camera drivers on Raspberry Pi, but kept failing at the compiling step. And so that took us a lot of time to figure out. Also, we were also stuck on trying to make the interface work, and then eventually we found out that the newest operating system for the Raspberry Pi that we initially installed actually did not work with the cameras. It's just that the operating system does not it's not compatible with camera drivers, so we had to switch to an older version of the operating system. So that eventually solved our problem, and it was actually a very simple problem to solve, but we were not familiar with Raspberry Pi enough to actually acknowledge that challenge. And so these two steps took us a lot of time to figure out, and we just took a lot of, yeah. And so our next step, we are almost finished on the camera system. We haven't finished in connecting everything together, and we still need to add an interface to the flashlight on the controlling interface that we're going to use on the computer. So next, Ishan will introduce to you more on how to make the flashlight work.
Hello, my name is Ishan Rayan. I'm a physics and economics major, and I'll be presenting this part of the section. In this part of the circuit, we have the flashlight, which was a pretty simple circuit to follow. It was just a transistor connected to a 10K resistor to a Raspberry Pi. The collector was connected to the flashlight and the 5-volt component, and then we have a emitter connected to the ground. Just the basic circuit was pretty easy to follow. One of the main struggles that we had with this was that we needed a better understanding of the Raspberry Pi, sorry, and how to mount and connect a transistor and resistor to a Raspberry Pi in a way that works with the coding as well. Mainly because the purpose of this whole thing is to be able to control it through the Raspberry Pi as a switch. That was our main struggle with this portion of the flashlight. However, in all regards, the system itself was not too difficult to understand and follow. As you can see on the left, we have it mantled on a red board and also some breadboards, and we got to work. Second part of this is the 3D printing process. So we used a Lowesbalt Taz Pro as our 3D printer. We required 3D printing to mount our boards onto the rovers so that it was just a more stable way than just duct taping them onto the rovers. This 3D printing also took a lot of time, was because the computers that we're using to access the Cura 3D printing software just ends up taking so much processing power and so much more time than expected. So editing and making all these little parts, as simple as they are, took a lot more time. We were able to, however, get some boards ready and made, such as the one that you see here. Even though this one was not the final design, it has some of the names printed on, as you saw in an earlier slide. And we were to get some boards out. However, one of our main difficulties was the time constraint of not being able to immediately design and access the 3D printing, but also having to learn about 3D printing since a lot of us come from a very lack of experience with that process. This part is the rovers. So in our design, we had 2 rovers. The top one is as you can see, we bought pre-made rovers. The left side of the top one is the rover before it has been dismantled. On the right side, it's been dismantled. The extra weight has been taken off. A new battery has been strapped on, a bigger battery, so that it lasts longer. And that is before any PCBs or any type of circuit is mounted onto it in relation to GLEAM. The bottom one is the central unit. As you can see on the left side, you have the pre-made, just bought rover. On the right side is our rover with the PCB mounted to it, as well as the circuits and everything, and how it should run. And one of the issues we had with this was mainly just trying to save weight and understanding how the rovers worked, because they both work in their own separate ways. The top one works with a steering wheel type of controller, while the bottom one doesn't.
This is all for our report. Thank you for your attention. We would like to make some acknowledgements at the end. We would like to thank our advisors, Thomas and Dave, for providing us crucial technical support. We would also like to thank Gabe, the TA for this project, for hosting the TA meetings and office hours, which helped us a lot in understanding this project. Last but not least, we would also like to thank the organizers of GLEAM. It has been an awesome educational opportunity for us, although it has been pretty overwhelming for us as well. We learned so much in such a short time, and it has been such a meaningful experience for all of us.